Good morning. Today's topic, multiple reactions. So what are these multiple reactions? Topic is multiple reactions. Okay. So multiple reactions, what are these multiple reactions? And what are the different types of multiple reactions? One, series reaction. And the multiple we have series reaction in which A will be giving R and R will be giving S with the red constants K1 and K2. This is one way. The other type is a parallel reaction. Parallel reactions means A will be giving R and A parallelly will be giving S also. This is one type of parallel reaction. And the other type may be A may give R and R may give S and A also may give S. A very more complicated reaction. And the other ways are, suppose I have a reaction A plus B gives R. Okay, here A may be giving R and B may be parallelly giving R. Okay, so these are the different types of parallel reaction. Actually, in industries, no, there are more complicated reactions. And those more complicated reactions are actually A gives R gives T, okay, and this A plus A gives T. There are some reactions called as Van der Waals reactions, Van der Waals, Denby. These reactions, no. Usually industrial reactions are more complicated. Industrial reactions will fall under these categories and they are more complicated ones. Like this, we'll be having some things like this. Okay. So what is my product? R. Okay, if my major product is R, if this is a major product which is required, what is happening here? A is again giving a different product T. So I have to stop this. I have to minimize this. Okay. So how do I minimize this? How do I minimize this? There are so this all can be studied under catalysis. Okay. So there are different ways of minimizing using a different catalyst or using the changing the conditions of working like temperature or pressure for gas phase reactions. So this is about the multiple reactions. So there are many reactions happening. So how do I minimize those? How do I minimize this path? Okay, and one way is adding catalyst. One way is adding using catalyst. One way is using by changing the temperature, and the other way is by having reactors, multiple reactors in series or multiple reactors in parallel. What do I mean by multiple reactors in series or parallel? So I can take a CSTR, CSTR and PFR you have studied, right? So I can have a combination of these things. So usually when PFRs are used, no, conversion is high. Conversion is high in PFRs, whereas in CSTRs, conversion is not as high as PFR. Conversion is low. So I can have one of the reactant in plug flow mode and the other reactant in continuous flow mode. In the sense, suppose I have let me take an example of semi-batch, which will be our next topic actually, multiple reactors. Okay, so for which the concentration has to be maintained minimum, it will be taken in continuous flow mode. Okay, for where the conversion is high, that will be taken in plug flow mode, the reactants, different reactants. Okay, so that will be actually our next topic. So we were actually what we were doing, how to minimize is by adding a catalyst. This catalyst may inhibit this reaction. It should be selected in that way, and by changing the temperature or by connecting the reactors in a different way, we can get maximum conversion for required conversion. Okay? The third one is series parallel reaction. Series parallel reaction. What are the series parallel reaction? Series parallel reaction. Suppose I will just take one reaction. A plus B gives R and R plus B gives S. Okay. So here what is happening? B is giving R. B is giving S. So here it is B is giving R. This is plus A, and B plus R gives S. So it is parallel with respect to B. I can call this is parallel with respect to B. And what is happening? So this A, no, A is giving R, R is giving S. So here A with plus B gives R, and the R with plus B gives S. So it is series with respect to A. This reaction is series with respect to A. Can you see? Yeah. Just make a note of this. Okay? So these are the different series parallel reactions. This is about series parallel, multiple reactions, under multiple reactions, series parallel and series parallel reactions. Okay? Next, I have a derivation of rate expression. Derivation of rate expression for these reactions. Okay, so in that first one, I'll take irreversible reactions in irreversible parallel reactions. Okay, the topic is next topic. What I covered in your material, it is irreversible reactions in parallel. This irreversible reactions in parallel. Okay, so let me take a reaction which occurs in parallel. What I have taken in the material is A gives R and A gives this. This is what I have taken. So let me take that only. So if I write a rate equation for this, it will be minus dCA by dt equal to K1 CA plus K2 CA. Okay, so you can now write this as K1 plus K2 into CA minus dCA by dt. Okay, so what I'll do, I take the limits CA not CA. Okay, one more step, I'll repeat. So this can be written as minus dCA by CA is equal to K1 plus K2 into dt with the limits CA not to CA, 0 to t. Okay, and the value is minus ln of CA by CA naught is equal to K1 plus K2 into t. This is one reaction, sorry, one equation which you have to remember. Okay. The other equation is second part for the same equation is, now I can write dCr by dt also. What is dCr by dt? dCr by dt is K1 CA. And this dCr can be written as delta Cr by dt. What is delta T? What is delta Cr by delta T? Cr minus Cr naught by T minus T naught. Okay, will be equal to K1 CA. You see, yeah. Next, similarly, I can write for S also. dCs by dt is equal to K2 CA. So delta Cs by delta T will be equal to Cs minus C naught by T minus T naught is equal to K2 Ca. Okay. So from this 1 and 2, what can I conclude? 1 divided by 2 concludes delta Cr by delta Cs is equal to Cr minus Cr naught. Cr naught usually will be 0 divided by Cs minus, because products, so initially there is no concentration of the products. Cs naught is equal to K1 by K2. This one equation you should remember. Or what can I write? If initially if these two terms are 0, if the concentration of the products are 0, no, Cr by Cs can be written as K1 by K2. Make a note of that. Next is what? Next is irreversible reactions in series. Look at this. irreversible reactions in series. In series. Okay. What reaction I have considered? Same one I took. Okay. A gives R, R gives us K1, K2. Okay. So what I'll do, I'll start with minus RA equal to minus dCA by dt equal to K1 CA, which implies CA is equal to CA naught e to the power of, sorry, CA naught e to the power of minus K1 T. Okay. Next, R I by its product. So it is dCr by dt, which is equal to K1 CA minus K2 CR. Similarly, I can write for RS also. It is dCs by dt, which is equal to K2 CR. So these are the terms. Now what I do, I take this equation 1. Okay. So I'll take this equation 1 and let me solve for it. dCr by dt will be equal to K1, and I'll substitute for the CA from this, okay, as CA naught e to the power of minus K1 T. K1 CA naught e to the power of minus K1 T. Okay. Let me take the equation of minus K2 CR. I now solve this equation as dCr by dt is plus K2 CR is equal to K1 CA naught e to the power of minus K1 into T. Okay. Now the solution for this equation, we know complementary functions and particular integral, where dy by dx plus py is equal to q, and the solution for this is y into e to the power of integral p dx is equal to integral of q into e to the power of integral p dx plus c. This is the solution. Okay. So here, what is y? Y is equal to CR. What is x? X is equal to T. Correct. Q is equal to K1 CA naught e to the power of minus K1 T. Now the solution will be, you able to see, the solution will be CR e to the power of P, Py, no, P is, one second, P is equal to K2, I didn't list that, P is equal to K2, e to the power of integral of K2 dt, which is equal to integral of Q is K1 CA naught e to the power of minus K1 T into e power, you see that? Into e power integral of p dx, same thing, K2 dt into dt plus c. Okay. So now I'll solve this and the solution of the, let me continue with the solution here. CR e to the power of K2t is equal to integral of K1 CA naught e to the power of minus K1t e to the power of minus K2t plus c. Okay, and the integration of this will be K1 CA naught e to the power of minus of this is plus K2, right? So it is K2 minus K1. K2 minus K1 into T by K2 minus K1 plus C e to the power of K2T is equal to, okay. So now see, now the next thing is at T is equal to 0, initial time, right? At T is equal to 0, CR is equal to CR naught, which is equal to 0. Okay, CR naught, which is equal to 0. Next, what I'll do, if I put these values, I can get an expression for C. Okay. So therefore, C is equal to what? see this term will go 0. So this will be minus k1 by k2 minus k1 into Ca naught e to the power of k2 minus k1 into t. Okay, or this can be written as, I'll just retain that. Okay, so we have got an expression for C. One second. Yeah, this is what t. This term will be 1 because e power of 0 will be 1. So therefore C is equal to k1 Ca naught by minus k1 Ca naught by k2 minus k1. Okay, that's it. Okay. So let me continue here, the other part of the board. So what will be CR now? It's a very lengthy derivation. Now what will be CR now? So therefore CR will be, I'll be substituting, CR will be, and I'll try to send this e to the k2 t, no, I'll send to RHS. Okay. So it will now be k1 by k2 minus k1 Ca naught e to the power of this goes up and I'm left with minus k1t. Okay. Plus what is C? C is actually minus k1 by k2 minus k1 Ca naught e to the power of minus k2t. Okay, so this is and I can also write this as Cr by Ca naught equal to k1 by k2 minus k1 into e to the power of minus k1t minus e to the power of minus k2. This is one equation which you have to remember. Fine. Let me proceed. This is one equation which you have to remember. Very lengthy equation, very lengthy derivation. I have to proceed still. Next thing is to find CR max. CR max. Okay. So CR max and T max. Okay. So T will be equal to T max and dCr by dt is equal to 0. Okay. I have a marker here. Getting lighter. Okay, dCr by dt is equal to 0. Now what I'll do, I'll try to find dCr by dt. Okay. So for this equation, dCr by dt will be equal to k1 by k2 minus k1 into minus k1 e to the power of minus k1t minus into minus plus k2 e to the power of minus k2t. This is equal to 0. This is equal to 0. Okay, this is equal to 0. What I'll now do, so what I'll do, Ca naught I had left out, right? Ca naught I should write. Okay. Now the thing is, see, this term cannot be 0. Why? I have Ca naught term here. If there is Ca naught, what do you mean by Ca naught? Initial concentration. Initial concentration cannot be 0. So this term cannot be 0. Okay. So what should I do now? The other term will be 0. Okay. So the other term is 0. So here I can now write this as what I have taken, k1 by k2 or okay. Same thing I'll repeat. I have taken the different way. Minus k1 e to the power of minus k1t plus k2 e to the power of minus k2t is equal to 0. What I do? I take ln on both sides. So it will be ln k1 minus ln K1. Minus ln K1, and it will be plus plus K1t, because I have minus here, no? This is minus, so it will be minus into minus plus K1t plus ln K2 minus K2t is equal to 0. So this can be written as ln of K2 by K1, okay, is equal to T max. T will be T max, I said, no, divided by send this to the other side, K2 minus K1. K2 minus K1, okay, or this can also be written as T max will be equal to ln of K1 by K2 by K1 minus K2. I take the equation in this form for further substitution. Okay. Now I have found this T max. The next step is to substitute this T max in the equation which I already have. So you have to rewrite this equation, but I can proceed as such. After that, we will continue here. This will now be, you see, CR by CA0 is equal to K1 by K2 minus K1 into e power minus K1 into ln K1 by K2 by K1 minus K2 minus e to the power of minus K2 into ln K1 by K2 by K1 minus K2. Okay. So now, and this becomes CR max now. After substitution of T max, now this equation becomes CR max. Okay. So the final equation for CR max will be okay. Make a note till there. Next thing is, we know, see, e to the power of minus x ln y, e to the power of minus x ln y is equal to y power minus x. Okay. So what is in the ln now? So what can I write? Therefore, CR max by CN0 will be equal to K1 by K2 into e power, I should change this, right? So it is, y is what? K1 by K2 minus x is minus K1 by K1 minus K2 minus K1 by K1 minus K2. Okay. Minus, I am going correctly, minus again K1 by K2 into minus K2 by K1 minus K2. Okay. So this is the equation. Next what I do? CR max by CA0 will now be K1 by K2 into, I take this outside, so it is K1 by K2 into minus K1 by K1 minus K2 into 1 minus K1 by K2 into, see, this is minus K2 and what comes here now? This goes up, so it is plus K1 by K1 minus K2. Okay. So this cancels. It cancels, okay. So what am I left with now? Cancels, and this is stuck. So therefore, CR max by CA0 is equal to K1 by K2 1 minus K1 by K1 minus K2 into 1 minus K1 by K2. Okay? Yes. Note that. So finally, what do I have? Finally, what do I have? Oh my God, such a lengthy equation. Finally, what can I write now? So this will be K1 by K2. Okay. So this will go up here. K1 gets cancelled. It is minus K2 by K1 minus K2. And this will be K2 minus K1 by K2. Correct? Okay. So with all that, no, I had just left this term. I had left to carry this term only there when I did. Okay. So I should have carried that, right? It's not just K1 by K2. It is K1 by K2 minus K1. K2 minus K1. Did I miss that? Did I miss that? No. One second. K1 by K2 minus K1. Okay. I think in here we are correct. Yes. Okay, from here, let me do a bit change. This check file not here. This check file. It will be okay. So I have to put the brackets here, right? And it's just because of missing this term K1 by K2 minus K1. Okay. That is correct. Okay, so this will now be K1 by K2 minus K1 into K1 by K2 into minus K1 by K1 minus K2 into K2 minus K1 by K1. So these terms go. These terms go. And finally, I got the equation. What is that equation? So let me write the equation. Oops, I got really tired doing this derivation. One place, if you miss, then the entire thing goes off. CR max by CA naught will now be CR max. I'll write the final equation, and the final equation is K1 by K2 to the power of K2 by K2 minus K1. This is a very important term which you have to really remember. You'll be having problems on that because usually rate constants will be given and you are asked to find when, at what temperature, time does the Cmax occur on, find the value of Cmax. So you will have questions on that. Next is, yeah, we have still not found S. Okay, so yes, of course, this is very simple. In 2 minutes, let me finish off. No, make a note of this. Yeah. To find CS now. To find CS. Okay. So how do I proceed to find CS? Simple. Okay. CS, we know CA naught is equal to CA plus CR plus CS. Okay. Therefore, CS will be what? CA naught minus CA minus CR. So what I'll now do, CA naught minus, in place of CA I'll substitute as CA naught e to the power of minus K1t minus, for CR also I should substitute. What is that CR? K1 CA naught by K2 minus K1 into e to the power of minus K1t. Can you see? This is getting lighter. Marker here. Okay. Minus k1t minus e to the power of minus k2t. Okay. So this is what? What are we trying to find now? We are trying to find C. Yes. Okay. So CS will now be CA naught into 1 minus, let me try to take e to the power of minus k1t common. Okay. E to the power of minus k1t if I take, it will be 1 minus k1 by k2 minus k1. Correct. One, am I correct writing this? Yeah. Okay. Then what is left out? Minus into minus plus k1 by k2 minus k1 into e to the power of k2 t. Okay. Oh, I should get a negative sign, means I should put plus here. This is with negative sign, right? Okay. So this will be CA naught into 1 minus. So K2 minus K1 gets cancelled. What am I left with? K1 by K2 minus K1 e to the power of minus K1t plus K1 K1 by K2 minus K1 K2 t. What is CR? K1 gets cancelled. This is K2. K2. So this will be a CS. Okay, this is called CS. Next, very simple thing. 2 lines only. If K1 is first case lesser than K2, CS is CA naught into 1 minus e to the power of minus K1. Okay, and if K1 K2, CS is equal to CA naught into 1 minus e to the power of minus K2. Okay. Yes, this is your derivation. Oof, it's a very lengthy derivation. Maybe in the class I take more than 1 hour to derive this. Okay, anyway, we have completed it. Let's wind up. Thank you.